Right now, you're traveling through space at 67,000 miles per hour. Earth spins, orbits, and rockets through the galaxy while you sit listening to this. But that is just the beginning of a cosmic race that started 14 billion years ago and will not stop until the universe itself faces its final moment. We will witness colliding galaxies, dying stars, and black holes that devour light itself. We will travel to the very end of time, where even atoms fall apart and reality might tear like fabric. We will discover forces so powerful they stretch space faster than light can cross it. Like and subscribe as we embark on this journey to the edge of everything. Prepare yourselves. We begin now. Music, you cannot feel it, but right now you are screaming through space faster than a bullet. Earth spins on its axis at over 1,000 miles per hour at the equator. Picture yourself standing on a massive carousel that never stops spinning. While you sleep, eat, and go about your day, you are whipping through space at speeds that would make a race car look motionless. This rotation creates the day and night cycle, but it is only the first layer of our cosmic velocity. But spinning is just the beginning. Earth also orbits the Sun at 67,000 miles per hour. Imagine a racetrack so enormous that it takes an entire year to complete one lap. That racetrack is Earth's orbital path, and we are all passengers on this high-speed journey around our star. In the time it takes you to read this sentence, Earth has traveled over 200 meters along its orbit. The ancient Greeks thought Earth sat perfectly still at the center of everything. They believed the stars and planets danced around us in crystal spheres. We now know the opposite is true. Earth is like a passenger on a cosmic bullet train that never stops for anyone. Every breath you take happens while hurtling through the void at speeds that would terrify early astronomers. This orbital dance has continued for over 4.5 billion years. Earth has completed that same path around the Sun more than 4 billion times. Each orbit brings changes in seasons, weather patterns, and the delicate balance that keeps life thriving on our planet. Without this precise speed and distance from the Sun, Earth would either freeze into a lifeless ice ball or burn into a scorched wasteland. Yet, even this incredible velocity pales compared to what astronomers discovered when they looked beyond our solar system. They found that our entire solar system, including Earth, the Sun, and all the planets, moves through space as a single unit. We are not just orbiting the Sun. We are all traveling together on an even grander journey. The Sun itself orbits something far more massive and mysterious. Our solar system rides along like a passenger in a cosmic vehicle racing toward a destination that will change everything about our cosmic neighborhood. But compared to what comes next, our journey around the Sun looks like a gentle stroll through the park. The Sun is not standing still either, and it drags our entire solar system along for a ride that defies imagination. Our solar system orbits the center of the Milky Way galaxy at 514,000 miles per hour. Picture our solar system as a single seat on a Ferris wheel, so massive that one complete rotation takes 230 million years. Earth, Mars, Jupiter, and all the planets are passengers on this galactic carnival ride that has been spinning since before the dinosaurs existed. The Sun completed its last full orbit around the galaxy when reptiles ruled Earth. Dinosaurs lived and died during just a fraction of one galactic year. Human civilization has existed for less than 1% of our current trip around the galaxy. We are cosmic newcomers riding on an ancient journey that started billions of years ago. At the center of this galactic Ferris wheel sits a black hole 4 million times more massive than our Sun. This monster, called Sagittarius, a star, acts like a cosmic anchor that holds our entire galaxy together through its immense gravitational pull. Every star in the Milky Way, including our Sun, dances around this invisible giant in the galactic center. As we orbit, our solar system bounces up and down through the galactic plane like a horse on a merry-go-round. Sometimes we ride above the galaxy's disk, sometimes below it. This cosmic bobbing motion takes about 60 million years to complete one full cycle. Scientists believe these galactic tide changes might influence climate patterns and even mass extinction events on Earth. Our solar system has completed only about 20 orbits since it formed. We are currently about halfway through our 21st journey around the galactic center. Each orbit exposes us to different regions of the galaxy, different radiation levels, and different cosmic hazards that could affect life on Earth. The Milky Way itself contains over 200 billion stars, most with their own planets. As we orbit the galactic center, we pass by stellar neighbors that come and go like ships in the night. Some stars we encounter are older than our sun. Others are stellar babies just beginning their nuclear fires. But our galactic journey faces an approaching collision that will change everything about our cosmic address. In 4.5 billion years, our galaxy will collide with its nearest neighbor in a cosmic crash that will reshape the heavens. Andromeda, the closest major galaxy to the Milky Way, races toward us at 250,000 miles per hour. Picture two massive cities speeding toward each other on a collision course that cannot be stopped. Andromeda contains over 1 trillion stars compared to our galaxy's 200 billion, making it the larger opponent in this cosmic wrestling match. This galactic collision will create fireworks visible from billions of miles away. Stars will be flung from their orbits like sparks from a campfire. Some solar systems will be ejected into the darkness between galaxies, becoming cosmic wanderers with no galactic home. Others will spiral inward toward the merged galaxy's new center, where two supermassive black holes will eventually combine into an even more powerful monster. The collision will not happen like two cars crashing. Instead, the galaxies will pass through each other like two swarms of bees flying past each other at high speed. Individual stars rarely collide because the distances between them are so vast, but the gravitational forces will stretch, twist, and reshape both galaxies into completely new forms. Earth and our solar system will likely survive the collision, but our cosmic address will change forever. We might end up in the outer reaches of the merged galaxy or closer to the center, where radiation and gravitational forces are more intense. The night sky will look completely different, filled with new constellations and a brighter galactic center. Astronomers have named the merged galaxy Milka, combining the names of both original galaxies. This new galaxy will be larger, more massive, and more complex than either of its parents. The collision will trigger intense star formation as gas clouds collide and compress, creating stellar nurseries throughout the merged galaxy. By the time this cosmic collision occurs, our sun will be nearing the end of its life cycle. Earth might already be uninhabitable due to the sun's increasing brightness and heat, but any civilizations that exist during the merger will witness one of the most spectacular shows in cosmic history. Yet, even this galactic collision is just a local event in a universe that faces a much more dramatic fate driven by forces we are only beginning to understand. The universe is not just expanding. It is accelerating its expansion faster than anything we thought possible. Space itself stretches like taffy being pulled apart by invisible hands. Every second, the fabric of reality grows larger, creating more distance between galaxies without them actually moving through space. Picture a balloon being inflated where every dot drawn on the surface moves away from every other dot as the balloon expands. That is exactly what happens to galaxies in our expanding universe. Edwin Hubble first discovered this cosmic expansion in 1929 when he measured the light from distant galaxies. He found that every galaxy beyond our local group is moving away from us, and the farther away a galaxy is, the faster it recedes. This became known as Hubble's law, and it revolutionized our understanding of cosmic evolution. But in 1998, astronomers made an even more shocking discovery. They expected the universe's expansion to be slowing down due to gravity pulling everything back together. Instead, they found the expansion is speeding up. Something mysterious is pushing space apart with increasing force, overpowering gravity on cosmic scales. The most distant galaxies we can observe are racing away from us at speeds approaching the speed of light. At a certain distance called the cosmic horizon, galaxies recede faster than light itself can travel. This creates an invisible barrier beyond which we can never see. No matter how powerful our telescopes become, those galaxies effectively disappear from our observable universe forever. This acceleration means that in the far future, galaxies will move apart so quickly that beings living in one galaxy will not be able to see any others. The night sky will become dark and lonely, containing only stars from their own galaxy. Future astronomers will have no evidence that other galaxies ever existed. Scientists estimate that space expands by about 7% every billion years. This might seem slow, but it compounds over cosmic timescales. In 100 billion years, the universe will be over 1,000 times larger than it is today. Every distance between galaxies will have grown by that same enormous factor. The force driving this acceleration remains one of the biggest mysteries in science, but its effects grow stronger every moment. An invisible force stronger than gravity controls the fate of everything in existence. Dark energy makes up 73% of the universe. Yet we cannot see it, touch it, or directly measure it. We know it exists only because of its effects on cosmic expansion. Picture an invisible giant pushing apart every piece of matter in the universe with steadily increasing strength. That giant is dark energy, and it grows more powerful as the universe expands. Unlike gravity, which pulls things together, dark energy pushes space apart. The more space exists, the more dark energy fills it, creating a runaway effect that accelerates universal expansion. Every cubic inch of empty space contains dark energy that contributes to this cosmic push. As the universe grows larger, more space means more dark energy, which causes even faster expansion. Scientists have proposed several theories to explain dark energy. Some believe it represents the energy of empty space itself, a quantum foam that fills every corner of reality. Others suggest it might be a new type of field similar to magnetism or gravity, but operating on cosmic scales. A few radical theories propose that dark energy might be leaking into our universe from other dimensions. The discovery of dark energy earned the 2011 Nobel Prize in Physics. But it also created one of the biggest puzzles in science. The amount of dark energy we observe is far different from what quantum physics predicts. This discrepancy, called the cosmological constant problem, represents a gap in our understanding of fundamental physics. Dark energy affects every galaxy, star, and planet in the universe. It works against gravity's attempt to hold cosmic structures together. In our local group of galaxies, gravity still wins and keeps nearby galaxies bound together. But on larger scales, dark energy dominates and drives galactic clusters apart at ever-increasing speeds. Future space missions plan to map billions of galaxies to measure how dark energy has changed over cosmic history. These observations might reveal whether dark energy remains constant or grows stronger over time. Some models predict dark energy could eventually become so powerful that it tears apart galaxies, stars, and even atoms themselves. As dark energy continues its relentless push, it sets the stage for cosmic changes that will affect every star in the sky. Every star in the universe is burning through a finite fuel supply that will eventually run out completely. Stars are like cosmic campfires that consume hydrogen fuel to produce the light and heat that warm planets and drive the chemistry of life. Our sun burns through 4 million tons of hydrogen every second, converting it into helium through nuclear fusion. This process has continued for 412 billion years, but it cannot last forever. Inside every star, a constant battle rages between gravity trying to crush the star inward and nuclear fire pushing outward. As long as hydrogen fuel remains, nuclear fusion provides enough outward pressure to balance gravity's inward pull. But when the fuel runs low, gravity begins to win this cosmic wrestling match. The most massive stars burn their fuel fastest, living short but brilliant lives. A star 50 times more massive than our sun will exhaust its hydrogen in only a few million years. These stellar giants shine so brightly that they can be seen from billions of miles away. but their intense fires consume fuel at an unsustainable rate. Medium-sized stars like our Sun live much longer, burning fuel steadily for about 10 billion years. Our Sun is currently middle-aged, having consumed about half of its hydrogen supply. In another 5 billion years, it will begin running low on fuel and start the dying process that affects all stars. The smallest stars, called red dwarfs, burn fuel so slowly that they can shine for trillions of years. These cosmic misers stretch their hydrogen supply across time periods longer than the current age of the universe. Long after our Sun dies, red dwarfs will still be burning their fuel with the efficiency of a car that gets incredible gas mileage. But even red dwarfs cannot escape the fundamental law that governs all stars. Finite fuel means finite lifetimes. Every star will eventually exhaust its nuclear fuel and face the same inevitable fate. The universe has already begun this transition from a time of stellar birth to an era of stellar death. New star formation has been declining for billions of years as the universe uses up the gas and dust needed to build stars. When stars begin to die, they become monsters that consume the very planets they once protected. Our Sun will transform into a red giant in about 5 billion years, swelling to over 100 times its current size. Picture our familiar yellow star suddenly growing so enormous that it engulfs the orbits of Mercury and Venus like a balloon inflating around toy cars. This stellar transformation marks the beginning of the end for our solar system. As a star exhausts its core hydrogen, it desperately begins burning helium and other heavier elements to maintain nuclear fusion.